Algebra, Unit 3, Lesson 2, Notes 2, Rate of Change and Slope. Rate of change is a ratio that describes, on average, how much one quantity changes with respect to a change in another quantity. If x is an independent variable and y is the dependent variable, then rate of change equals change in y over change in x. And we can use the delta symbol here to represent our change. So change in y over change in x. That represents the rate of change. So we need to find what the y values change by, what the x values change by, and then divide them. So let's take a look at the first example, letter A. Find the rate of change and then explain its meaning. The table shows the cost of computer games. So if we look at our table, we have the number of computer games, which is our x, our independent variable, and we have the total cost, which is in dollars, which is y, or dependent variable. So we need to figure out how much the y values increase by. To get from 78 to 156, we are actually adding 78. To get from 156 to 234, we are also adding 78. If you weren't sure how to get there, you could subtract the two values to see what it changes by. Now let's do our change in x. Our change in x from 2 to 4 is plus 2. And from 4 to 6 is also plus 2. Again, we have our rate of change is the change in y over the change in x. The change in y is 78, positive 78, and the change in x is positive 2. Remember, fractions are division, so divide that out. 78 divided by 2, and we get a rate of change of 39. But what does that mean? Well, our label for our rate of change will be our y label over our x label. Our y label is total cost, so dollars, and our x label is number of computer games. So what this means is the rate of change is $39 per game. You can go ahead and try letter B. Letter C. The graph shows the number of people who visited U.S. theme parks in recent years. Find the rate of change for 2000 to 2002 and for 2002 to 2004. Explain the meaning of the rate of change in each case. Which interval has a greater rate of change? Lastly, describe how the different rates of change are shown in the graph. So let's break this apart piece by piece. The first thing we have to do is find the rate of change for the two different years, or two different groups of years, I should say. So let's look at just 2000 to 2002. So we are looking here. In 2000, the attendance was 317. In 2002, the attendance was 324. Well, to find the change, I need to subtract those values. So here we have our y-axis and our x-axis. Remember, rate of change refers to change in the y over change in the x. So to find this, again, we have change in y over change in x. And let's label this 2000 to 2002. To find the change in the y values, we're going to subtract the y values. 324 minus 317. And to find the y values, the change in the x, we're going to subtract the x values. Well, the x values are the years, 2002 and 2000. So 2002 minus 2000. Now, it's important to notice in my numerator, I chose to put 324 first, which is right here. And if you notice, 324 matches with the year 2002. So 2002 must also go first in the denominator. That's very important. You will have slopes and rates of change that could be negative. So let's go ahead and do these calculations. 324 minus 317 is 7. And 2002 minus 2000 is 2. Divide it out, and we get 3.5. But what does that mean? Remember, we take our Y label over our X label. Our Y label is millions, attendance, so people. And our X label is year. So it's 3.5 million people per year. So that's the first part of my answer for 2000 to 2002. Now let's do 2002 to 2004. So here are my values for 2002 and 2004. We are still doing change in Y over change in X. Our Y values, we have 325 minus 324, and I chose to use 2004 first. So 2004 minus 2002. Well, 325 minus 324 is only 1, and 2004 minus 2002 is 2, which equates to 0.5, and it's going to have the same label, million people per year. And I should probably label that this is 2002 to 2004. Okay, so that answers the first question. Explain the meaning of the rate of change in each case. We actually did by labeling it million people per year. And it was an increase, so we could, if we wanted to, throw the word increase in there. So we could say 3.5 million people per year increase, and same down here, increase. Okay, then it says, which interval has the greater rate of change? Well, the interval that has the greater rate of change is the one that's going to be a bigger number. So the interval with the greater rate of change is the 2000 to 2002. So let's go ahead and jot that down. The interval with the greater rate of change is 2000 to 2002. Lastly, describe how the different rates of change are shown in the graph. Well, how can I see that 2000 to 2002 had the greater rate of change? Well, here's 2000 to 2002, and here's 2002 to 2004. Look at the steepness of these rates of change, of these lines. Do you notice how 2000 to 2002 is steeper than 2002 to 2004? Well, that's how I know it has a greater rate of change. So let's write that down in words. We can also tell because the line between, don't mind my abbreviations here, the line between 2000 to 2002 is steeper and that would answer the last question. Letter D. A family is traveling from their home to a vacation resort hotel. The table below shows their distance from home as a function of time. Determine the average rate of change between hour 2 and hour 7, including units. So we are focused on hour 2 and hour 7. We're going to do this similarly to what we did in C, except for we're given the points and in a table instead of on a graph. So our rate of change is still going to be change in y over change in x, which means I'm going to subtract my y values and then divide it by the difference of the x values. The question is, which is x and which is y? Well, unless it's stated otherwise, our time, hours, minutes, seconds, months, years, days, time is always going to be x, our independent variable, which would leave distance to be y. Again, unless otherwise stated, time is almost always our independent variable. So if we're looking at our change in y, we're looking at the change in distance. Well, the change in distance would be 480 minus 140. I used my larger value over here, 480, so I must use 7 first. It matches with the 480. So 7 minus 2 is the change in the x values. Let's do the calculation. 480 minus 140 is 340. 7 minus 2 is 5. Divide it out, and we get 68. It said to include units. Again, we do our y label over our x label, so it would be miles per hour. So 68 miles per hour. Using the values in the table, which time interval shows the least rate of change? Well, we already know the rate of change from 2 to 7 here, but which one would show the least rate of change? Let's look at our interval from 0 to 2. Let's do that one first. So using our change in y over change in x for all of these, from 0 to 2, our change in y values would be 140 minus 0 and 2 minus 0. For our x, we would get 140 over 2, which equals 70. Let's look at the next interval, 2 and 5. So again, we've got we'll do 375 first. 375 minus 140 over 5 minus 2. We get 235 over 3, which equates to 78 and a third, or 78.3 repeating. Lastly, let's look at 5 to 7. So our change in y is 480 minus 375 over 7 minus 5. We get 105 over 2, which equals 52.5. 52.5 is definitely the smallest interval, or I'm sorry, the smallest rate of change. So let's just write that in words here. Hours 5 to 7 shows the least rate of change. The slope of a non-vertical line is the ratio of the rate of the change in the y-coordinate, the rise, to the change in the x-coordinate, the run, as you move from one point to the another. It can be used to describe a rate of change. So slope is the rate of change. Slope describes how steep a line is. The greater the absolute value of the slope, the steeper the line. Because a linear function has a constant rate of change, any 2 points on a non-vertical line can be used to determine its slope. The slope of a line can be positive, negative, 0, or undefined. So we have 4 choices over here. Let me zoom in. We have a positive slope. Our line is increasing. It goes up from left to right. Negative would go the opposite way. It decreases or goes down from left to right. A slope of 0 is a horizontal line. Your change up and down is 0, but it moves left and right. So that would be a slope of 0. And then undefined. It moves up and down, but it doesn't move left and right. So any vertical line is actually referred to as an undefined slope, which means it's not a function. If you think back to the vertical line test, it would 100% fail the vertical line test and therefore is not a function. The other three, however, are functions. Our slope formula, which was rate of change is change in y over change in x, and I did mention that the change in y and the change in x refer to really subtraction. So we can actually write that out as slope, or m, equals y2 minus y1 over x2 minus x1. Your x1, y1 is your first point, and your x2, y2 is your second point. It doesn't matter which one you assign as your first or second, just be consistent. So let's do a couple of these together. Let's look at A. Find the slope of a line that passes through each point, each pair of points. Determine if the slope is positive, negative, 0, or undefined. So it doesn't matter what you label. So I'm going to label this as my first point, and we have x coordinates, then y coordinates, so x1, y1. And our second point, x2, y2. Notice the 1s and the 2s are subscripts. Those refer to them being labels, not exponents. So our slope, make sure you write the equation out, m, or the formula I should say, m equals y2 minus y1 over x2 minus x1. We don't know the slope, that's what we're finding. y2, from here you just plug in your values. y2 is 5. y1 is 0, divided by x2 is 1, x1 is negative 2. Notice how I have 1 minus already before I even put in my other value. It will be 1 minus negative 2. 5 minus 0 is 5, and 1 minus negative 2 is 3. With slope, you can leave it as a fraction. In fact, it's usually easier to manage slope when it's in a fractional form. Don't be confused with a mixed number. We want to keep it in fractional form, not a mixed number. So leave it as improper. And my result is a positive number, so this slope is positive. If you got a negative answer, your slope would be negative. Let's do one more of these. Letter B. We'll label this point 1 and this point 2. Our slope equals, and again I want you to write the formula out, y2 minus y1 over x2 minus x1. Slope equals y2 is 0 minus negative 4, and then x2 is negative 2 minus negative 2. 0 minus negative 4 is positive 4. We'll just write it here. And negative 2 minus negative 2 is 0. I want you to plug that in on your calculator and tell me what you find. If you notice, it doesn't give you an answer. It gives you some form of error depending on which calculator you're using. You cannot divide by 0. This is referred to as undefined. So our slope is undefined, which means it has no numerical answer. It's just undefined. Letter E. Now we're still going to use our slope formula, but this time we're given the slope and we're missing a value. We're going to label like we normally do. x1, y1, x2, y2. Write your formula. Slope equals y2 minus y1 over x2 minus x1. This time we're given the slope. So we need to plug 2 in where m is. y2 we don't know. We have a variable, so put that variable there. R minus our y1 is 6 over x2 is 4, x1 is 3. Let's simplify what we can here. We have 2 equals r minus 6, and I can do 4 minus 3, which is 1. what we can do, we have a whole number on the left as a slope. If we had a fraction, this would work as well. But I want to make it a fraction. Actually, fractions are easier to deal with, so I'm going to make it a fraction. I can actually cross multiply to solve for r. 2 times 1 is 2, and I'm going to bring this up here, equals 1 times r minus 6. Make sure you distribute that. So it's really 1 times r minus 6. 2 equals, distribute the 1r minus 6. 1 times negative 6 is negative 6. We're going to add 6 to both sides, and we get 8 equals 1r, or r. So our unknown coordinate is 8. Let's jump down to the next section. Average rate of change over an interval. To find the rate of change over an interval, you find the slope between the two endpoints. So really, you're just finding slope. It's okay that it's not necessarily a straight line between those two intervals. It wants to know the average rate of change. So if we look at our graph here, and this graph refers to both A and B, if we look at our graph, we were concerned with the x value of negative 8 and the x value of 2. Well, if you look at your graph, the y value, where x is negative 8, so here's, let me get my arrow, here's negative 8. The y value is positive 3. So jot that down. And for this x value of 2, if we go to x is 2, go up to our line here, it's actually also at 3. And really what we're doing is just finding the rate of change, or the slope, as we have been before. So this will name our first point, x1, y1, and we'll name this our second point, x2, y2. We're going to solve it the same way as before. Slope equals y2 minus y1 over x2 minus x1. We don't know the slope. We have 3 minus 3 up top over 2 minus negative 8. Our slope equals 0 over 10. Well, 0 divided by 10 is 0, so our average rate of change is 0. When you're looking at this notation for letter B, you've got an interval. What it means is you want x values greater than or equal to negative 1 and less than or equal to 1. So really it's just like saying your x value is negative 1 and your x value is positive 1. And we can treat it like we did for letter A. So if we look at our x value of negative 1, find your y value, which is 7. And our x value of 1, our y value is negative 1. And then we find the slope as usual. I'm going to go ahead and let you finish letter B. I just wanted to set it up for you. For letter C and D, you're going to treat it just like you have before, only this time instead of a graph, you have a table. So for letter C, when you have x value of negative 5 and x value of negative 2, you're just going to peek over at those y values that correspond. Same thing with, and this is for letter C. Same thing for letter D. You're looking at your x value of 0 and your x value of 9. So you can go ahead and do letter C and D as well. When you're plugging in and finding the average rate of change for an equation, you're going to just take your x values and plug them into y, or plug them into your equation to get your y value, and then find the rate of change. So I'm going to skip E and I'm going to do letter F with the interval. So we have an x values from negative 2 all the way to positive 4. So we're concerned with really just these two x values. So what I'm going to do is I'm going to plug them into the equation. Our equation is y equals x squared. Plug in the x value one at a time. Y equals negative 2 squared. Notice how the negative 2 is in parentheses. Y equals, well, negative 2 times negative 2 is positive 4. We'll label this our x1 and our y1. Now let's plug in negative 4, or I'm sorry, positive 4. So y equals x squared. Plug in positive 4. It's a good habit to automatically put them in parentheses so you don't forget them later. 4 times 4 is 16. So we're going to label this x2 and this y2. And then we treat it like we have been before. Go ahead and plug them into your slope formula. Slope equals y2 minus y1 over x2 minus x1. Slope equals, well, our y2 is 16. Our y1 is 4. x2 is 4. x1 is negative 2. Slope equals 16 minus 4 is 12. 4 minus negative 2 is really 4 plus 2, which is 6. So our average rate of change is 2. Go ahead and try the rest on your own. And again, remember, let me scroll up for you. Letters G and H are very similar to letters A and B. So go ahead and follow what we did there.